Okay, in this example 3 of finding the area of a segment, we are asked to find the area of one of the 4 segments shaded in the black here that is formed by a square with the size of being 6 feet that is inscribed in a circle. So the square in the red right there, and each of the sides is 6 feet. And these black lines are called the radii. They connect the center of the circle and the vertices of the square. The formula for the area of a segment in this example, the same as the one that we discussed before, which is the area of a sector minus the area of a triangle. And because we only need to find the area of one segment, we only need to take a look at one of these 4 sectors, either this top one or each of the other 3. We can just go ahead and find the area of all 4 segments together, or the total area of all 4 segments eventually. Now, what is the formula for the area of a sector? In this case, I am going to attempt to use pi over 360 degree multiplied by pi multiplied by the radius of the circle square minus the area of a triangle, which is 1/2 times the base of a triangle times the height of a triangle, like that. So how do we figure out the central angle theta, the radius of a circle, and the base and height of a triangle? This right here, this formula for the area of a sector is the degree form of the area of a sector, because I'm attempting to find the central angle in degree form, not in the radian form. Well, if we go all the way around, that's going to give us a total of 360 degrees. And because we have 4 central angles right here, we can find the degree of these 4 central angles by taking the total degrees, 360, and divided by how many central angles we have, which is 4. So 360 divided by 4 is going to give us 90 degrees for each of these central angles. So the central angle is 90 degrees. So 90 degrees over 360, and then we bring down everything else. This is r squared, which is the radius square, minus 1/2 times b times h, which is times base times height. So how do we figure out the radius, the base, and the height? Well, to do that, first is we select one of these 4 triangles. Either this one, this one, this one, or this one. I'm going to select the one on the right. Selecting the one on the right, I'm going to draw the apothem, which is the green dashed line right there. And remember that the apothem intersects with the base of the triangle perpendicularly. So that's the right angle right there. We know the base of a triangle is 6 feet, so we're good on that. So we just have to find the height of the triangle and the radius of the circle. Well, to do that, we take a look at the triangle on the right that we selected here, and we choose either the top half or the bottom half. I'm going to go ahead and select the bottom half of this triangle. So drawing the bottom half of that triangle is going to look something like, let's see, maybe like that. So that's the apothem. That's the radius of a circle. Let's see the time. Here we go. And that is half of the base of the triangle that we select. Well, let's see. We know that this is 90 degrees because this is the angle that is formed by the intersection of the apothem in the green dashed line here and the base of a triangle right there. Now, if we go back to this figure, the apothem bisects this central angle. So since this central angle is 90 degrees and it gets bisected, we know this half is 45 and this half is 45. So the bottom half, which is right here, is 45. If this is 90, this is 45, then by the triangle angle sum theorem, the leftover has to be 45 as well. With this triangle right here, using the 45, 45, 90 triangle property, opposite to each of the 45 angles are the short legs. denoted by a variable. I'm going to call it x. Opposite to 90 degrees is the hypotenuse of this triangle, which is also the radius of a circle, denoted by the formula x times square of 2. However, for this part, we know that it is going to be 3 feet because this part right here is only half of the base of the entire triangle that we select. So since the base is 6 feet, half of it is going to be 3 feet. So 6 divided by 2 equal to 3 feet. If this x is 3 feet, this x has to be equal to 3 feet. And this is the height of the triangle. If x is 3 feet, then the hypotenuse, which is the radius of a circle, is going to be 3 times square root of 2 feet. Guess what? We have the base of the entire triangle, which is 6 feet. Now we know the radius and we know the height. All we have to do is replace all of the unknowns with their respective values. So this is going to be what? I'm going to write it over here, make it easier to see. So this is going to be, let's see, 90 over 360 is going to give us 1 over 4. Keep the pi. The radius square, which is going to be 3 times square root of 2 square. Minus 1/2 times the base of a triangle, which is 6, times the height of the triangle, which is 3. From here, it's just a matter of simplification in algebra. So let's see. This is going to be, well, let's see, 3 times square root of 2 square. Well, that's going to be 3 square. Multiply square root of 2 square. 3 square is going to be 9. Square root of 2 square is just going to be 2. So 9 times 2 is going to be 18. So we got 18 pi over 4 minus 6 times 3 is 18. 18 times 1/2 is going to be 9. So we got 18 pi over 4 minus 9 feet square. And suppose that I'm supposed to keep the answer in terms of pi. This is the value of the area of each segment. So one segment has the value of the area being this. But since we have 4 segments, all we have to do is that we take the value of one of them, which is right here, and we multiply that by how many segments we have, which is 4. So really, the total area of all segments is the amount of segments we have, which is 4, multiplied by the value of the area of each segment, which is 18 over 4 times pi minus 9. Yeah, we'll simplify this fraction, 18 over 2, a little more, by recognizing the fact that 2 is the greatest common factor of both 18 and 4. So 4 divided by 2 is 2. 18 divided by 2 is going to be 9. So distributing the 4 into each term inside the parentheses, I'm going to have 4 times 9 pi over 2, which is going to give us 36. Yeah, 36. Actually, no. What am I doing? Why am I doing this? No, forget this. So we got 4 times 18 over 4 pi minus 9. With the 4 right here, if we distribute it, we're going to have 4 times 18 over 4 pi minus 4 times 9. With the 4 right here cancel out, we're left with just 18 pi minus 36 feet square. This is the total area of all 4 segments.